Victor, which will just tell us what the ASTON group of people is thinking about.
Okay. It's not really a project. I think it started as a project, or I'm sure it started as a project, and I will come back to that in the slides. But we changed our opinion a little bit because of the moving environment we are living in. So, but at least I'll try to explain it in the next slides. I think the background of the slides is for a lot of people known. No, that's not my background. But that picture is, yeah, there are a lot of individual people, and it's coming a nice play out of it. And at the end, it was even successful. I think 2 happy people at least, minimally. And perhaps you can do the same with these kind of projects on optical networking. So something about ASTON. It was the title stands for a step towards optical networking. The reason is that optical networking is not really short term. We see that real pure optical networking is something in 2 or 3 years at least for the national research networks. But we see that the real optical network could envisage new services and that kind of things in our environment, and we have to be aware of that. We have to test these ideas and look at that. Why doesn't it work? Okay. So first of all, I'll say something about what we did in the past. We made first a project plan and then a white paper, and then some evaluation points concerning future projects. We started in 2001, and mainly because Task Force NGN was looking at and discussing and evaluating and talking and about optical networking within the TERENA environment. And then some company, Fleck Telecom, provided us with, or at least they said that they could provide a pan-European and American bandwidth network up to 2.5 to 10 gigabit within Europe. So we took that opportunity, of course, and around that we made a project plan. And the major activity in that project plan, I think, was the bandwidth on demand service. And I'll come a little bit more to the detail in the next slide. But at least it's most of the time that end users want a bandwidth, perhaps 100 megabit or a gigabit or 10 gigabit. And you need a facility, a service, and a methodology in your operational networks to provide such bandwidth on demand. And the project plan was around that. Of course, in 2002 there was a downturn of the telecom, and yeah, it's a pity, but Fleck also went down, at least for this project. And so we changed our idea a little bit. So we said, okay, let's at least express our interest for the 6th framework program. We think that the ideas that Task Force NGN, TERENA, and Fleck made together are so interesting for our group that we want at least to express our interest towards the 6th framework program. So we did that, and as a result of that, we also were more looking into more detail of what is bandwidth on demand. A lot of people don't know what bandwidth on demand is, or there are lots of definitions on bandwidth on demand, like is it layer 1, layer 2, layer 3, is it multi-domain, single domain, what kind of technologies are you using, and a lot of issues, and we have put them then somewhere on the web where you can read different ideas about bandwidth on demand, and at the end they have to be unified, of course. A little bit later in this year, we decided let's not do a project anymore. Let's not have a project plan in the sense that the NRENs themselves are going to have a project on optical networking. We saw other projects emerging, EGEE, GRANDE. These people also talk after me. So we saw there were competent partners available who could lead projects of this size, because they're quite big, a lot of money involved, a lot of project management and so on. So we thought, okay, let's at least put down our ideas, publish them to everybody so that other projects can use our data and information we are working on. The corporate information or issues we found important in the process is, again, bandwidth on demand. I don't know if it is optical bandwidth on demand, but most of the people just want bandwidth. Some people want, of course, other layers, and we also have to provide it. It's a little bit related to the idea of customer-empowered networks. End user is able to ask for a connection. I know it's a hobby horse of mine, but it is a term which also was in the ATM times known. So, but I think now that customer empowered networks are really possible. We have the protocols, GMPLS is there, or at least MPLS is there, the experience is there in operational networks. So I think that we changed a lot since these 10 years, and hopefully in this optical environment we are now seeing we can use this information and all these standards we now have. So of course also about capacity, 10 gigabit Ethernet or 10 gigabit SDH is quite common in some networks at least. Because of that commonality, I think it's important that we also investigate the next step in interfaces. As you know, the traffic grows with a factor of 2, at least the real traffic grows with a factor of 2. I assume that the capacity of the links also should grow, perhaps with a factor of 2. And that's why in 2 years we should go to 40 gigabit. And we want to prepare at least the vendors and the operational managers and so on, that this kind of interfaces are needed. At this moment, the 40 gigabit interface market is stuck because of the downturn. I think, yeah, people must be aware that the research networks could be a possible customer over there. Pure optical technologies and switching, that's the other activity or issue which is very important, of course. We know it's a little bit further on, 2-3 years, perhaps later, but at least it's something that will be coming, the real optical switching and so on. And we just want to know it. We want to talk with people, universities and so on, and we must know what happens over there. Because of that bandwidth on demand idea that customers can ask perhaps bandwidth, or that national research networks can change their bandwidth much more fast and so on, there is the idea that the routing could be much more meshed than nowadays. The connectivity and so on could go to a more meshed model of links and connectivity. It could be that the present day routing protocols can't handle that. So we have to investigate, can BGP, OSPF, ISS, or whatever protocol you think, can that handle this emerging idea of multiple links and so on. And so that's a very important item also. The other thing is layer 2 or layer 1 protocol, simpler ones. At this moment, IP, that's still the protocol, of course, for years. But IP is based now on SDH, POS interfaces, or ATM, or whatever. But it could be that IP directly over a color, DWDM, or an optical link would be better to do that. So we have to investigate the new protocols for that. How do we transport IP directly over, for instance, the DWDM channel? And of course, network management and the monitoring of this kind of networks will be very important in looking after this aspects. It's not anymore one domain. I think everybody knows that. At least 5 domains, that's the minimum in my opinion. And so everything we think about should be able to handle multi-domains and not only one. So things which are developed, let's say, in a metropolitan area network or a local area network, lots of applications are, for instance, only developed for a local area network and never thought about that there is a big, difficult world there. That has to be part of the projects. So these are the things that are important in our opinion that other projects or that projects should do in the future if they are looking at optical networking, bandwidth on demand, and high speed stuff. So as ASTON itself, we are not a project anymore. We are not a competitor of other projects. That's at least what I want to say. We are more a think tank of the national research networks who think together. And I think that ASTON in some way even thinks that the more projects, the better it is, because diversity is always good. A monopoly doesn't work, so some competition between a few projects would be handy. Of course, the problem exists that if a lot of NRENs are going to one project and not going to 2 projects, then only perhaps one project will have a good life. But I think we need more than one project for this kind of things. It must include, of course, the mentioned issues, otherwise I wouldn't have stated them. We want if there are multiple projects, in some way we want interoperability between the equipment. The NRAN environment is not a mono-vendor environment, so interworking at layer 1, layer 2, and layer 3 I think is not a problem. We have experience with that, but at least at the other 2 layers it's very important that projects will interwork, or that within a project multiple vendors or multiple providers are inside, or that there is a real package looking at that kind of things. Connectivity, there are networks who are big and they have lots of 10 gigabit links to everywhere, and some can afford that. Some other networks can't anymore because of the changing environment, also in the NRAN environment, I think. So I also would like to see that the projects allow not only direct connectivity, LABDAs they are called, but I call them more 1 gigabit or 10 gigabit or 2.5 gig as the H links, so direct connections for doing things, or perhaps a tunneled version that you do a layer 2 tunneling over an existing IP network. Because it's not always the bandwidth which is important, it is the idea how to work with this kind of technology. So it's the service models, the experience of new paradigmas or something like that. Test to incorporate applications, grids are already mentioned. I think without the users it will be very difficult. So what we did is write that white paper, it's on the web, the URL will come, and in principle we send it out, and we hope that GRANDE will take over these ideas, and that we get a nice, and as the play yesterday, it ended at least very nice. So there's the information where you can get more, where you get more information, and that's it. That's all I have to say about the ASTON idea, and how we would like to stimulate other projects in doing worldwide connectivity on optical side.
Thank you. And now while we